Okay, we'll talk about making a parametric equation for a line and then a line segment. Okay, here's point A at negative 2, 3 ordered pair. And remember, vectors have a horizontal and vertical component. A position vector, remember position vector, that's where the tail is at the origin. So any ordered pair that's based on a reference to the origin can really be a position vector, right? It goes over negative 2 and up 3, okay? So remember that, that's how we write vectors, with a horizontal and vertical component. We break it down to an x and y, kind of like we've done with the ship. All right, so I've got this point A, and here's point B at 3, 6. So negative 2, 3, 3, 6. And I'm going to have some point, let's see. So here's my line. Let's say out here is point P. And I don't know, and then it keeps going. All right? Just to keep in mind, I'll get to something, or I'm going to get ahead of myself here, but AB times a certain amount will get me AP. Maybe it's 1.5 or whatever. Remember, the term scalar is used in vector terminology, where it's just a number that doesn't have any direction. You just got a magnitude to it, but no direction. So that's a scalar, it's just a number. So I can, this vector AB, which is 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, has a horizontal 5 up 3. I can multiply that vector by a scalar to get AP. Maybe it's, like I said, it might be 1.3, 1.5, or whatever. Okay. All right, that being said, let's talk about how I can write a parametric equation using this line. Let's start with here, my origin, point O. Okay? I want to get a line that contains AP, let's say. Okay? AP. And I don't know where P is right now, that's the point. But I do know that vector OP equals, it's the resultant vector of this, OA and AP. So notice I go tail to head and then tail to head. So vector OA plus vector AP, that equals my resultant vector of OP. And remember how we can get a resultant vector? We can kind of have our vectors with XY and XY and combine them for, the final XY. Okay? All right. So we said making these vectors OA and AP equals my resultant vector OP. But now guess what? I'm going to break this down. I'm kind of like almost factor out. I'm going to make, remember I said AB? If I multiplied by some figure, a scalar would get me AP. Well, that's what I'm going to do, and I'm going to call it T. So I'm going to rewrite this with OP equals OA, vector OA, which I know is negative 2 up 3. It equals OA plus, guess what? T, the old T, times AB. So some value of T times AB will get me AP. AB, okay? So AB times T gets me AP. So OA plus T times AB will give me, okay, will give me this OP. So I've still got the same basic equation. So that's going to be, now T can be other things, right? T can be 2, 3, it can give me any point on that line, okay? So this is going to be kind of, philosophically, that's going to be my formula here. So for getting my parametric equation. So what's vector OA? Well, this part's 0, right? It's negative, so it's basically negative 2 up 3. So vector negative 2, 3, plus T, okay? Now here's where we have to do a little, if you don't have the grid, But this vector AB, t times AB, what's the horizontal component? 1, 2, 3, 4, 5. Or we could do this. What? 3 minus negative 2. Okay, 0.2 minus 0.1. That's my horizontal. And 3 minus negative 2, or just counting your squares, is 5. So the horizontal component is 5. And then the vertical is my y minus y. 6 minus, this is 3. 6 minus 3. Or just, what do we do? 1 over 5 up 3. Okay? So my equation for my line is going to be my OA plus my T times AB. And like I said, this will get any point on that line depending on what T is. Okay? So let's distribute this out. I've got negative 2, comma 3 plus, what's T times 5? That's going to be 5T, and T times 3 is 3T. So that's my horizontal, that's my vertical. So I'm going to kind of stack them here, or you can, as long as you know what you're adding, horizontal to horizontal, x to x, y to y. What's my horizontal here? It's 5T, and my vertical is 3T, and the net result is my equation. Okay? It is negative 2 vector, this is my equation for this line for any point on there, negative 2 plus 5t, and t could, and since it's a whole line, what's t going to be? It's going to be negative infinity to infinity. Remember, lines are infinite. Okay, so t is going from negative infinity to positive infinity. And then my vertical component is 3 plus 3t. Okay, and let's check it out. What if t is 0? This goes away and this goes away, right? So I'm left with what? If t is 0, I'm left with negative 2 comma 3. My original, just this vector here, because remember, it's t times ab. T times ab. If ab is, if t is 0, we don't get ab. So I'm just left here. So that checks. That's a good check. What if t is 1? So I'm getting I'm getting this OA plus 1 times AB. So I go this far. So my resultant vector would be this right here. And that checks with what? That'll get me to, okay? And the 1AB should get me what? Over 3 up 6. Okay? Alright, so let's plug in 1 here. We should get that point 36. Okay? So if I plug in 1, what's 5 times 1 is 5, minus 2 is 3. I plug in 1 here, 3 plus 3 times 1, 3 plus 3 is 6. So that's your 3, 6. Okay? Alright? What's important about this is, I just told you not only how to get a line by, this is my equation for a line. Hopefully you can see it. Negative 2 plus 5t, 3 plus 3t. And that's an equation for a line when I've got all real numbers for t. I can make it a line segment by what? Restricting my t. So if I restricted my t from less than or equal to 1 to greater than or equal to 0, I just established a formula for the line segment AB. Remember, line segments are just from point to point. Okay, so when a t is 0, I just have this point here, and then when all the way up to 1, where I get all the points up to, including b, but not past b, because only t times 1 gets me there. Okay. So that's what we're going to do tomorrow, okay? Hopefully you might have to rewind this and play it again. Hopefully that made some sense. I did practice, all right? Have a happy night.